Hello, my name is Vera. I'm an application engineer from Alpha Technologies. Today, in this webinar, we are going to discuss the measurement of blowing and curing reactions for sponge rubber compound by using RHO-meter. The sponge rubber compound has two reactions in the curing process. One reaction is that the blowing agent decomposes and releases the gas when the temperature reaches its decomposing temperature. And the released gas enables bubble cell creation in rubber compound. The other reaction is the cure reaction, which generates cross-link bond and increases the compound stiffness. The balance between the curing reaction and the blowing reaction is a key factor to determine bubble cell density and structure, which relates to the final product's performance. If the blow reaction happens too early before the cure reaction, it can result in an open cell structure. The bubble cells collected to each other, and the sponge production will have low density. If the blow reaction happens after the cure reaction, the gas decomposed by the blowing agents will be restricted. The bubble cell is small. It will generate closed cell sponge products. It is even possible to have low bubble cell generation when the blow reaction happens too late. So the balance of blow reaction and cure reaction needs to be monitored to ensure sponge product consistency. How can we measure the balance between cure and blow reactions? Here we are presenting the testing solution from RHO-meter. The test sample is contained and sealed in the RHO-meter die cavity, which is formed by two dies. The nodal die offers sinusoidal shear oscillation deformation to rubber sample with the defined frequency and angle. The torque transducer in upper die measures torque response from the testing sample. With the pressure transducer configuration, the pressure changes against the upper die is measured. This torque and pressure transducer allows the RHO-meter to measure the blow reaction and cure reaction from sponge rubber compound simultaneously. The decomposition of blow agent releasing gas builds up the pressure in the sealed die cavity. The more blow agent decomposed, the higher pressure is made. By measuring the pressure change, we can know the blowing reaction intensity. But the vulcanization reaction will make compounds stiffer and increase torque, and we can know the cure reaction progress with measuring torque change. The direct relationship between the measured pressure and the amount of gas in closed die cavity can be explained by Boyle's law. According to Boyle's law, gas pressure multiplied by gas volume equals to gas molecules number times gas constant R and temperature T. The gas volume and temperature are constant in a cure test, which is defined by die cavity volume and temperature. R is also a constant, so the number of molecules formed during the blowing agent decomposition is proportional to the pressure rise in the RHO-meter die cavity. When we proceed the rheological test to measure both blow and cure reactions, the sample loading volume is essential to the success. When the sample loading volume is excess and 100% fill the die cavity, there would be too much pressure from the sample against the upper die and prevent the measurement of blowing reaction. The pressure curve will show high value at the beginning and then reduces with sample cures. But the S-ply curve records torque rise because of vulcanization reaction with minor influence from blowing reaction, offers the best testing sensitivity for cure. With partial cavity field application, the initial die cavity pressure is reduced, and it enables to measure the whole pressure changes during blowing reaction. The time at pressure starts raise from minimum pressure represents the blow agent starts decomposition, and the more gas released, the higher increased pressure is measured. The pressure rising up amount and rising up rate relates to blow agent decomposing gas amount and speed. The elastic torque curve offers the true stiffness changes of sponge rubber sample as a result of blow and cure reaction. The optimum die cavity fill amount is determined by the pressure measurement of different sample weight. As the curve shows here, The sample weight at the top difference between minimum pressure and maximum pressure is good to ensure test sensitivity for blowing reaction. If the sample weight is over, the pressure measurement could be restrained. The true gas amount formed by blue agent decomposition cannot be acquired. If the sample weight is less, the sensitivity could be poor to monitor variation in produced batteries. The sample weight variation should be controlled within plus minus 0.01 gram of the target weight to get good repeatability, and the uniform circular sample shape and thickness helps to less test variation. The interest data points to judge blowing reaction include the minimum pressure on the pressure curve, the maximum pressure, and the difference between maximum pressure and minimum pressure, which relates to the blowing agent decomposing gas molecular number. The maximum pressure rate represents blowing reaction intensity. The higher maximum pressure rate, the faster blowing agent decomposition speed. The actual sponge expansion and density could vary for different pressure and torque curve shape. The blowing reaction starts earlier or later than the Curie reaction could get different bubble cell structure. The Curie percent at the minimum pressure when blowing agent is about to start decomposition, and the Curie percent at the maximum pressure rate are the interest data to judge sponge rubber expansion and density. For summary, the blowing and Curie reactions of sponge rubber compound can be precisely and sensitively measured by raw meters. Full cavity field application is effective to get best sensitivity for Curie reaction, but it is limited usefulness to measure blowing reaction. Partial cavity field application is capable to provide best sensitivity for blowing reaction, and it can be used to determine the blow and Curie balance. The data points to judge bubble cell structure and sponge product density could vary for different torque and pressure curve shape. This is the application introduction for sponge rubber testing with raw meter. Thank you for your listening and have a good day.